And here's part 3. I'll just pick up where we left off. This next one here, you'll notice that this NO3 is not a simple ion. This is what we call a polyatomic ion. So that original title is true for this one, but these other ones are multivalent ions. This last one is a polyatomic ion. So we've got a polyatomic ion, meaning there's more than one atom that makes a poly. If you remember in math, multiple sides. A polygon is a multi-sided object or shape. So a polyatomic ion is an ion that has more than one atom inside. So let's take a look at this. Well, let's write. We've got Ba is barium. That's a group 2 element, so it's going to have a charge of 2 plus because it's going to give up the electrons. You'll need to get this from somewhere. I can't imagine you'd be asked to memorize this, but this is a nitrate ion, so NO3. And nitrate has a charge of -1. So we'll just put minus. So if we do our crisscross, like we've sort of undone the crisscross anyways. So the 2 over here in the formula became the 2 plus over here. There's no number after barium, so that's a 1. That becomes the 1 minus over there. So this is barium nitrate. Barium is not a multivalent ion, so we don't have to worry about. We only worry about these Roman numerals if there's a possibility for it to be something else. But if you look at the so let's look at barium. We have to go down in the periodic table. We find barium. It's in group number 2, and group number 2 will always form +2 ions. It doesn't change. So we can go back to our chemistry review. So this just all we have to do is we write the metal first. We write the anion, the negative ion. This, by the way, this is you should have talked about this. Cation is a positive ion. Think of it this way. I always remember the T looks like a plus, and anion, the N would be that it's negative. So anions are negative, cations are positive. So bariums are, we write our cation first, our anion second. So our anion is the nitrate ion. So it's just barium nitrate. Okay, now we're going to undo it. We're going to do it the other way. We've got these the chemical names. We want to write the formulas. So now we look at this one here. We've got lead, but it's lead 2. So first we'll get the symbol for lead, which is Pb. Plumbum is the Latin word for lead. So that's where the Pb comes from. So we got Pb. We know that it's the +2 variant of lead because it says right in the name. And then nitrate is this NO3 ion. So NO3. And we know that NO3 has a -1 charge. Okay, so we can do our crisscross, where our 2 comes down over here, our 1 comes down over here. But because the 2 multiplies, the 2 tells me how many nitrates. Let me go back to this thing here, that note that we had. So we said lead, right, has a +2, so it's got 2 up hooks. That's a horrible hook. It's got two up hooks. Let's look at this nitrate, NO3, as an ion. It's one thing. So it's got 1 down hook, right? But I've still got the unconnected up hook from plumbum, or lead, I should say. So I'm going to have to add another nitrate ion. That has a charge of -1. So it's got a down hook. So it hooks up. So I've got 1 lead, but I've got 2 nitrates. So the way we write that, we write the NO3, and we say there's 2 of them. And so this is how we're going to do that. The crisscross method works the same way, provided you pay attention. And so we can say that the chemical formula for this is Pb and then NO3 with a 2 subscripted over there. So that tells me that there's 2 nitrate ions for every lead ion in this ionic compound. Next we have calcium carbonate. Well, we look up calcium, that's Ca. Calcium has a charge of +2 because it's a group 2 element. Carbonate is CO3, and if I'm not mistaken, that also has that's a -2. But that's information you're going to have. Somebody needs to give you that. I don't think you would be. I wouldn't expect you to memorize that. So the calcium and carbonate both have the same charge. So if we do our crisscross, this is an interesting sort of problem with the crisscross method, is that if I do that, I'm going to end up with Ca2. So I'm going to write this in red because it's not going to be our final thing. I'm going to have Ca2, CO3, and it says I'm going to have 2 of those. But and you may have talked about this, but if I have these two numbers, I look at them. If I can divide these two by the same number, then I do that. I want to have it in the simplest ratio, right? So if I have this 2 can be divided by 2, just like this one. So this just becomes 1 and 1. So then I end up with this formula here. It'll be CaCO3, and I don't have to worry about the 2's, right? But let's go back to that hook and ball method. This is where the hook and ball method comes in really handy. So I got my calcium, and I've got 2 up hooks, and I've got my carbonate ion, and I've got 2 down hooks. Well, the good thing is those 2 hooks add up, they combine with each other quite nicely. So all I need is 1 calcium and 1 carbonate ion to come together. So this one, the hook and ball method, will give you the formula directly. That other method, the crisscross method, it'll get you there. But you have to remember this last step there, that if I have to look at it, can I reduce that ratio to something simpler? The hook and ball method will take you there directly. So you can choose the one that you want to go with. So let's look at this one. So we've got lithium phosphate. So lithium is Li. It's a group 1 element, so it's going to be plus. And then phosphate is PO4, and this has a charge of -3. Again, someone's going to have to give you that information if you have something like this on your exam. So we can do our crisscross method or our hook and ball method. However we do it, we're going to end up with this formula here. We're going to have lithium 3, whoops, horrible P there, PO4. There's only 1 phosphate ion, but there's 3 lithium ions that have to combine with that. And again, if you did the hook and ball method, you'd see exactly the same thing. So let's go down to the next page. Here we come to another interesting part of the chemical naming. So what we've done in those first 2 here, that first set there that we looked at, those have been what we call ionic compounds. They're either just simple ions, the elements, the atoms become ions because they give up electrons, or we get these other weird things, these polyatomic ions, where with some elements come together, and the way they come together, they end up with a charge that then they combine now with something else, but they tend to stay together when we have chemical reactions. So nitrates will typically stay together. Not always, but in a lot of the simple chemical reactions that you would have looked at in this course, nitrates would have stayed together, phosphates would have stayed together, sulfates would have stayed together, carbonates and hydroxides. Although the hydroxide ion tends to recombine in different interesting ways fairly easily. But those other ions, those polyatomic ions, will stick together. Now we're going to look at, these are formulas here, or compounds here, that we call molecular compounds. And the difference here is, in all of those ionic compounds, the electrons just jumped over. Lithium gave up the electrons, and the interesting thing is, say I had lithium chloride. So if I have Li, it's got a charge of +1. Chlorine will take a charge of -1. Well, the thing is, in order for lithium to have a charge of +1, this electron that lithium had, it had to give it up. So this electron has to go somewhere. Well, chlorine takes the electron. So this electron that left lithium goes into the chlorine to make it a negative charge, and the lithium gets a positive charge, and then these two opposite charges attract each other, if you remember that stuff from grade 9 physics, the electricity unit. Well, these molecular compounds don't work this way. What molecular compounds do is they will share electrons. So carbon doesn't like to give up electrons. Phosphorus doesn't either. These ones, notice that these ones are the groups 4 and 5, and they tend to want to hold on to electrons, or even they could be other groups, but usually, or not usually, always, when you look at these things, if you notice in those the ionic compounds, let me go back up. If you look at these things, it's always a metal with a non-metal, right? So iron is a metal, chlorine's a non-metal. If you look in the periodic table, on either side of that diagonal line, the staircase line, those metalloids at the center along that line. But on to the right of that staircase line are non-metals. To the left of that are all metals. Well, metals will combine with non-metals in forming these ionic compounds. When I get two non-metals combining, they don't want it. The two non-metals both kind of want to hold on to the electrons. So because they both want to hold on to the electrons, neither one of them wants to give them up. So what we do, what the terminology we use is that they share electrons. Okay. I won't get into the structure of it because you don't really need to know that. But so because these share electrons, we have a different sort of way of naming them and talking about them. So the way we do this, we'll go from the chemical formula. You see, it's easier to go from. It's easy. In fact, it's quite easy to go either way when we look at this. So the things that we're going to look at here is, again, we'll write the first element in the chemical name. We just write the name as it is, and then we'll look at the number. So I've got carbon here. Okay, so I've got carbon, and then I've got chloride. But the thing is, I've got 4 of these chlorine ions, or chloride ions, and you got to remember these prefixes. So for 1, the prefix is mono. For 2, the prefix is di. For 3, the prefix is tri. For 4, the prefix is tetra. For 5, the prefix is penta. 6 is hexa. 7, if there is one, would be hepta. But I don't think you'd have to worry about that yet. But these ones you'll definitely worry about. So because this is carbon, and normally we would say mono carbon, not normally, but when it's the first element and it's only one, we don't bother with the mono in front of it. We just say the element name. And then this is chloride, so the second one will still end in IDE, so it'll be chloride. But because there's 4 of them, I'm going to say it's tetrachloride. So we get it right directly from the formula that's written. We have 1 carbon, so instead of monocarbon, we just leave out the mono if it's the first one. If it's the second one, we write mono to describe it, to say that it's only 1. So it's carbon tetrachloride in this case. Let's look at the next one. We've got phosphorus and bromine, so it would be phosphorus bromide. But because there's 5 bromines, and we look 5 is penta, this would be phosphorus penta bromide, right? Oh my goodness, we're running out of time already. So part 3 is done. Let me quickly do this. So I've got sulfur and oxygen, but there's 2 oxygen, so it'd be sulfur dioxide, and I'll rush the last one in so that the good end. I've got 2 nitrogens, so this would be dinitrogen, and 1 oxygen, so it's monooxide, but because it's monoxide. And we're done.